Download this code from codegive.com, link in the description below. OK, let's dive into the world of serialization and deserialization, covering the concepts, techniques, considerations, and code examples to help you master this essential process. What is serialization and deserialization? At its core, serialization is the process of converting an object or data structure, like a list, dictionary, or custom class instance, into a format that can be easily stored or transmitted. Think of it as taking a complex thing and turning it into a string of bytes or text that can be written to a file, sent over a network, or stored in a database. Deserialization is the reverse process. It takes the serialized data, the byte stream or text, and reconstructs the original object or data structure. Why use serialization and deserialization? Serialization/deserialization are vital for a wide range of programming tasks, including 1. Storing data * persisting objects to disk. A database or a file allows you to save the state of your program and load it later. 2. Transferring data * sending objects across networks, between servers, clients, or different processes on the same machine. 3. Caching * storing serialized objects in a cache, like Redis or MEMC8, for faster retrieval. 4. Inter-process communication, IPC sharing data between different programs or processes. 5. Deep copying * creating a completely independent copy of an object, often necessary to avoid unexpected side effects when modifying objects. Common serialization formats. Several formats exist for serializing data, each with its own strengths and weaknesses. *JSON, JavaScript Object Notation, a human-readable, lightweight format that's very popular for web APIs and data exchange. It's based on key-value pairs and arrays. *XML, extensible markup language, a more verbose and structured format than JSON. It's commonly used for configuration files and exchanging data between systems. *Pickle, Python-specific, a Python module that allows you to serialize almost any Python object. It's efficient for storing Python data, but it's not secure to use with untrusted data, since it can execute arbitrary code. Avoid using Pickle when you're receiving serialized data from unknown sources. Protocol buffers, Protobuf, a binary format developed by Google that's designed for speed and efficiency. It requires a schema definition to define the structure of the data. Great for high-performance applications. *MessagePack*, another binary format that's similar to JSON but more compact and faster to parse. *YAML, YAML ain't markup language, a human-readable format often used for configuration files. It's less verbose than XML and more powerful than JSON in some ways. *CSV, separated values, a simple format for storing tabular data. *Avro, a data serialization system developed within Apache's Hadoop project. It is often used with large-scale data processing. Serialization and deserialization in Python. Let's explore how to serialize and deserialize data using some common Python libraries. 1. JSON, JavaScript Object Notation. JSON is widely used for web APIs and exchanging data between applications. Key points about JSON. *JSON.dumps, converts a Python object, specifically a dictionary, list, or basic types, to a JSON string. *JSON.loads, parses a JSON string and converts it back into a Python object, usually a dictionary or list. *JSON.dump, writes a Python object to a file as JSON. *JSON.load, reads JSON data from a file and converts it into a Python object. Handling custom objects. You need to define a way to convert your custom objects into dictionaries, or lists of dictionaries, that JSON can handle. I've included to_dict and from_dict methods in the person class to facilitate this. Error handling. Wrap your serialization and deserialization code in try, except blocks to handle potential errors like type error. If your object isn't JSON serializable, JSON.JSON decode error, if the JSON string is invalid, and key error, if the JSON structure is different from what you expect. 2. Pickle, Python serialization. Pickle is a powerful module that allows you to serialize almost any Python object. However, be very careful when using Pickle with data from untrusted sources. Key points about Pickle. Pickle.dump serializes an object to a byte stream and writes it to a file. The file must be opened in binary write mode, WB. Pickle.load reads a byte stream from a file and deserializes it into a Python object. The file must be opened in binary read mode, RB. Security warning, never unpickle data from untrusted sources. Pickle can execute arbitrary code, so if someone sends you a malicious Pickle file, it could compromise your system. Compatibility. Pickle files are specific to the Python version they were created with. Unpickling a file created with a different Python version might lead to errors. *__repair___ method. The __repair___ method in the animal class is used to provide a string representation of the object, making it easier to debug. 3. Protocol buffers, protobuf. Protocol buffers are a binary serialization format developed by Google. They are efficient, fast, and language neutral. Using protobuf requires a bit more setup because you need to define a schema first. Installation. Steps *. 1. Define the schema in a.proto file *. This file defines the structure of your data. Let's create a person.proto file. 2. Compile the .proto file *. Use the protoc compiler to generate Python code from the .proto file. This code will contain the Python classes that represent the data structure defined in the schema. This will create a file named person_pb2.py. 3. Use the generated Python code *. Key points about protocol buffers. Schema based. You must define a schema in a.proto file. This provides a strong contract for the data. Code generation. The protoc compiler generates the Python classes from the .proto file. Serialized to string, serializes the object into a byte string. Parse from string, deserializes the object from a byte string. Efficiency. Protocol buffers are typically faster and more compact than JSON or XML, especially for large data sets. Language neutral. The same .proto file can be used to generate code in many different languages. Complex installation. Protocol buffers require that you install protobuf and the protoc compiler. 4. Message pack. Message pack is another binary serialization format that is similar to JSON, but more compact and faster to parse. Installation. Example. Key points about message pack. *miscpack.pack serializes an object to a byte string. Use _bin_type equals true encodes strings to binary. *miscpack.unpack deserializes an object from a byte string. Raw equals false decodes binary strings to UTF-8 strings. Binary format. Message pack is a binary format, making it more compact than JSON. Speed. Message pack is generally faster than JSON for both serialization and deserialization. Asterisk requires MISCPACK library. 5. YAML. YAML is a human-readable data serialization format that is often used for configuration files. Installation. Example. Key points about YAML. *YAML.dump serializes an object to a YAML string or file. *YAML.safe_load deserializes an object from a YAML string or file. Important, use safe_load to prevent arbitrary code execution from untrusted YAML files. YAML.load is unsafe. Human readable, YAML is designed to be easy to read and write. Often used for configuration files. Requires PyML library. General considerations and best practices. 1. Security. Be very cautious when deserializing data from untrusted sources, especially with Pickle. Use safer formats like JSON or protocol buffers if you're dealing with external data. 2. Versioning. When storing serialized data, consider versioning your data format. If you change the structure of your objects in the future, you'll need a way to deserialize older versions of the data. This is particularly important for protocol buffers and database migrations. 3. Error handling. Always wrap your serialization and deserialization code in try, except blocks to handle potential errors. 4. Performance. If performance is critical, benchmark different serialization formats to see which one works best for your data and application. Binary formats like protocol buffers and message pack are often faster than text-based formats like JSON or XML. 5. Data integrity. Consider using checksums or digital signatures to verify the integrity of serialized data, especially if it's being transmitted over a network or stored in an untrusted location. 6. Data compression. For large data sets, consider compressing the serialized data using algorithms like zip or zlib to reduce storage space and network bandwidth. 7. Object graphs. If you're serializing complex object graphs, objects that refer to each other, make sure your serialization library supports it. Pickle handles object graphs, but JSON typically doesn't directly. 8. Custom serialization logic. For complex objects, you might need to implement custom serialization and deserialization logic. This might involve writing to _dict, and from _dict, methods, as demonstrated with JSON, or defining custom serialization/deserialization functions for other formats. 9. Choosing the right format. JSON, great for web APIs, simple data structures, and human readability. Pickle, suitable for Python-specific data storage, but avoid with untrusted data. Protocol buffers, excellent for high-performance applications, language-neutral data exchange, and well-defined schemas. Message pack, a fast and compact binary format. YAML, ideal for configuration files. I hope this comprehensive guide helps you understand and use serialization and deserialization effectively in your Python projects. Let me know if you have any specific questions.